Welcome back, folks. Today I want to talk about some 9mm cases. These are a crazy two-piece design from Shell Shock Technologies. You might have seen them make the rounds on the big gun channels about a year ago, and I was very interested in trying these guys out and trying to reload them. So I reached out. They were kind enough to send me some to have a look at, and that's what I want to do today. They have a lot of advantages. They weigh half as much as brass. My test showed these are about 30 grains a piece, where brass is about 60 grains a piece. So that means a 115 grain bullet in brass weighs the same as a 147 grain bullet in the Shell Shock cases. So that's a significant amount of weight savings. They're +P+ pressure rated. They can be picked up with a magnet, which is kind of cool. The base of the case is a nickel-plated aluminum, and the cylinder is a nickel alloy stainless. They eject cool to the touch, which is pretty awesome. And this nickel alloy cylinder is supposed to have a higher tensile strength, which means that you don't have to crimp as much or seat your bullet as deep for them to get a hold of it. So that's pretty cool, and they're not supposed to split, chip, crack, or grow. And the flat bottom on the inside of the cylinder gives you about 2% more case capacity. The flash hole is noticeably larger, and at the inside of the case it kind of bells, or it's cone shaped for better flash dispersion. So lots of cool things about these cases, and I'm very interested to see how they're going to perform. So reloading these guys does require special sizing dies and a special sizing die and flaring die. They're made by a company called S3 Reload. You can buy them right there on the Shell Shock Technologies website, but yeah, I'm still not sure what that's all about. But these are made by a different company, but it seems to be a pretty close partnership. So on the S3 Reload YouTube channel, they've got an interesting video where he reloads a single case 32 times until his battery died in his camera. And I want to steal that idea and kind of take it to the next level here. I've been playing around with these guys a little bit, and I have worked up a +P+ load that I want to use to kind of torture test these guys. The bullet I'm going to be using is the 124 grain Hornady Full Metal Jacket. Just, standard Full Metal Jacket offering from Hornady. So I went over to the Buffalo Bore website and had a look at what their +P+ 124 grain ammo was running as far as velocity, and it was, they show a Glock 19 at 1,296 feet per second. That's going to be our test gun today as well, is just a plain old Glock 19. And I've worked up a load that's getting me right around 1,300 feet per second. Crazy high pressure. Do not try this at home. You're going to blow your face off. All of that stuff. So let's just take this crazy load, keep reloading it over and over and over today, and see if we can get these guys to fail. So it should be fun. Now, these cases come completely ready to load. They're sized, they're flared, they're ready for primer powder bullet. So the first loading is pretty boring. So I've already taken care of it. This is 30 rounds of loaded ammo in this little Glock magazine. So let's run out to the range. Let's shoot these first 30, and then we'll come back in. We'll talk a little bit about the reloading process, and then we'll take probably 5 cases and just start reloading them over and over and over again. So let's get out to the range. One thing I've learned as I've worked up these loads, these light cases absolutely launch out of the gun. So I've got a big tarp laid out. I'm hoping to, be able to catch these guys easily enough, but all right, as you can see, we got the chronograph out. First 30 rounds, let's see how they do. Okay, no function issues, average velocity of 1286. So I missed my mark by 15 feet per second. but it's close enough. So let me gather up all these cases and we'll head back to the reloading bench. Okay, now that we've got some brass ready for reloading, let's start out with having a look at the dies. You've got a resizing die and a flaring die. The unique feature of these dies is that this is spring loaded, and after the case goes up into the die and gets resized, it essentially pushes it back out so that you don't have to, so the shell holder doesn't have to pull it out, which could screw up the fitting between the two pieces, or at least that's the way I understand it. So you push it up in there and then the die itself pushes it back out. They also send a spare decapping pin, which is nice. So when I first took one of these guys apart, I didn't even know what I was looking at. It uses a spring like I've never seen before. This is the spring. It's a piece of rubbery plastic feeling stuff. I don't know if this is common in some industries or something. Maybe, it's probably just my ignorance, but I've never seen anything like this. This is the decapping rod, which basically just squeezes that up. This squeezes, and then this is your decapping rod here, which sits right below it. And that's really all there is to it. The decapping pin is a press fit. So if it needs replaced, you just grab it with pliers and pull it out, and then squeeze this guy in there. So pretty simple, but very interesting. Our flaring die is very similar. You've got the plug, the spring, a little spacer, and then this part that floats in there, which is what pushes the case out. So, but otherwise, the stem there looks pretty much like a standard flaring die, right? Your case is going to come up on there, get pushed up on there a little ways, and flare that case mouth for you. This also appears to come out with some tools like an Allen wrench there and an Allen wrench down in there somewhere, but no need to do that. It's just a little floating pin. So in goes our spacer, in goes our spring, in goes our decapping rod and spring. And we are ready to install these guys in the press. So step one of installing the dies is to remove this plug so that there's no spring tension and this can move freely. So you raise your ram or your shell plate or whatever you're working with, screw this down until it touches, and then tighten down your lock ring. Okay, so next it says to reinstall the cap screw and screw it down until it touches the spring. And you'll feel, it takes some force to compress this guy, but it's not bad. So that was down until it barely touched the spring, and then maybe just a little bit more, like an 1/8 turn. Now, these do require that you lube your cases. Normally, I would just hit them with a little bit of lanolin or something, spray lube. But since I'm doing a small batch here, I'm just going to use some Reading Imperial sizing die wax. So here goes our first one. And that's all there is to it. So just being a nervous person by nature, the one we just resized, it does seem to have increased the gap between our two pieces ever so slightly. So I'm going to go ahead and screw the spring down a little bit more. I don't know of any disadvantage to having the spring too tight other than, additional force needed to run the die. So yeah, there we go. There's a little bit more. So here's the next piece. Just this is just residual lube on my fingers from the last time. I'm not going overboard on the lube here. Yeah, there we go. That one seemed to come out a little bit easier. And you know what? I'm a bit of an idiot. The one I just did looks like, that gap is just about the same. So I grabbed a brand new piece of brass, or a brand new case out of the bag, and it's got the same gap. So that little bit of gap that I really won't be able to show on camera is normal. All right, so there's two sized pieces that are ready to go. I guess I could back that spring out just a touch now, but I'm not going to worry about it. All right, for the expander die, same deal. We remove the cap to relieve spring pressure. we put a sized case into the die. Actually, I need to back this out a little bit more. So we take our size case, put it in the die, and then run it up. And then screw down the die until we feel it make contact with the case. Then we drop the ram and screw it in 3 turns, 3 full turns. Let me double check myself here. Yep, 3 full turns. And then we tighten our lock ring. So we reinstall our cap. Same deal, we screw it down until we feel it touch the spring. I'm going to go a little bit more, because why not? And now this is supposed to be our starting position that we can adjust from. So let's see what this does. So I can definitely visually see a little bit of flare there. Let's grab a bullet. This would probably be okay. Yeah, you know what? I'm just going to stick with that. Second case, yeah, that's just fine. All right, let's do a few more. Resize. Flare. Ready for primer. So rather than prime on the press here, I am going to use a hand primer just so I can really get a good feel for how these primer pockets are feeling. They feel just as tight here on our second loading as they did on the first. So far so good there. And I'm going to bump my powder charge up just a smidgen. Try to get those extra 15 feet per second that we were short. On the bullet seating side of things, you know, there's nothing special. I'm just using a standard Lee seating die and a Lee factory crimp die. You know, I think I might screw that flaring die down just a little bit more. These are a bit, you know, they're being a bit of a pain in the butt to keep straight. It's not bad though. All right, firing number 2. All right, so I do have a few stray cases laying on the ground around here. So these guys, I just sharpied them in, sharpied them red. So let's get to it. Okay, so the first shot registered 1,404 feet per second. I think my chronograph has lost its freaking mind. Nah, it's in the sun now, so sometimes they go a little goofy. The rest of them were all in the 1290s. So we're going to call the load good. I'm going to go pick up some brass, and I'll tell you what, let's go into high speed mode. So I'll talk to you guys again when something interesting happens. All right, guys, looks like we finally managed to kill one. Let's get back to the bench, have a closer look. All right, folks, I felt sure we'd get 4 or 5, but we made it all the way to 11. Having said that, this was almost a pretty bad failure, I think. Almost got a case head separation. So we ended up with a split right above the case head. It had nothing to do with the junction, you know, between the two pieces of the case. It was just a weakened spot there, right along the bottom of the cylinder. You can see a little bit of sunshine coming through there. That's bad. So, you know, you can see the gas escaping caused the vast majority of the damage here. So that was okay. My gun's okay, everything's okay, I'm okay. I just noticed a bunch of extra gas, you know, come out of the breech area, but otherwise, you know, it fired normally. So if you're wondering to yourself, like, why didn't he test it next to brass? Like, wouldn't that have been a more interesting test to see, you know, which one lasted longer? Guys, brass had absolutely no chance in this test. I wouldn't have felt safe firing brass more than once or twice. And like I said, I really expected 4 or 5 firings to wipe out the primer pockets in these guys maybe. But that was the shocking part. These primer pockets still felt awesome all the way through. They got dirty, and I did hit them with a primer pocket scraper a couple times just to get the junk out of there. But the pockets here at 11 firings still feel awesome. Nice and tight, not the least bit loose. So since the primer pockets never got loose, you know, this right here around the case head is where you would expect this guy to fail in this factory Glock barrel, you know, sloppy Glock barrel. So I am incredibly impressed. And in case you're not impressed, I was using an accurate powder, and the Western Load Guide, whom, you know, that Western makes accurate powders, they have 9mm plus P data. I was almost 15% above their max load for 9mm plus P. This was stupid, crazy, ridiculous pressures. And like I said, I think brass would have had zero chance. Getting 10 good loadings out of these guys and then failing on the 11th is just, it's just very impressive. This also puts to rest any questions I had about the long-term durability, about the compression fitting or junction between the two pieces of the brass. So this is good stuff. Did I mention that this stuff is actually cheaper than brass? Let me, hang on. Yeah, so the prices range from, for a bag of 500, they're 12 cents a piece. And if you buy a, you know, big, huge bag of 10,000, they're as little as 8 cents a piece. And the die set, I think it's $100 on the Shell Shock website, but the S3 Reload website has them for about $80, which isn't exactly ridiculous for some really well-made dies. So if you shoot a bunch of 9mm, the cost to get into it, it just isn't that bad. And then you're, you know, like I said, you're buying cases that are cheaper than brass. You know, while preparing for this video, and then in this video, I've shot this plus P plus load in at least 100 pieces without any problems, without a single malfunction of any sort, until this one case finally failed on its 11th firing. I'd love to repeat this test with a gun designed for this sort of ammo, like, you know, a competition gun that's made for like 9mm major power factor with a, you know, with better chamber support, especially around that base of the case. I have a feeling these guys would hold up. So the rims and the case head did get chewed up a little bit, you know, just by the gun. The ring that you see around the primer comes from my breech face. It's got that, you know, ring of junk in there, and that just kind of imprinted itself onto the cases over the firings. Now, standard pressure loadings, I mean, this stuff would be, you just load it forever. But brass is pretty much that way, right? Your primer pockets will eventually get loose just from the friction of inserting and removing primers, and this would, you know, I'm sure this would be the same way. And like I said, over on the S3 Reload YouTube channel, they've got that video where they shot one 30-something times with a, I believe that was a standard load. So I think that's where we'll leave it. I'm impressed. I would load this stuff up with self-defense ammo and start carrying it tomorrow. I have absolute total confidence in these cases at this point, and I hope this video made you understand why. It's impressive stuff. Right now, I think they're just 9mm, or actually I know they're just selling 9mm. I'm not sure if they plan to expand into other cases. I certainly hope they do. I don't know that the materials involved would be appropriate for bottleneck cases, but hopefully they'll expand their line of, you know, of straight wall cases over time, and I will look forward to trying them out. So if you enjoyed today's video and you want to help me replace the recoil spring that I curb stomped all day long, come on over to patreon.com/reloading. It's the best way to support the channel, and I will see you guys next time.